fuck?
Love math?
I'm just so tired.
That too.
That's what I said.
Oh.
Okay, today, here's what we're going to do. We're going to do, I don't love math like that. All right, so,
This is
Um,
math.
Alright, so here's what we're going to do today. We're going to do one example of kind of each type, kind of know like which one you should pick, that type of thing. Once we're done with this, then the examples that we are going to get new homework today. Now we know we had homework, I think it was due Wednesday this past week. If you haven't turned in that one there, page 552. If you haven't turned that in, that is on the next semester or next quarter grade. That one. That's the first assignment on the next quarter. That one. So make sure that one gets turned in if you didn't, because it's technically late. But that one is due. That was due actually technically yesterday. I think is the latest time. Okay. Today we are going to get a new assignment. It's pretty easy. The first couple classes they got pretty far into it. I'm giving you until Wednesday to do it because I don't know what's gonna go on. Because I know next week we have like ITDS testing and other things. So I want to give you at least a couple days you can work on it. So just kind of keep that in mind. Let's do one example today. It's over SOHCAHTOA. You need a scientific calculator in front of you right now. No cell phones. Put your cell phones away. I don't want to see them at all. So put them away. And not to your laps, like get rid of them. Okay? I don't want to see it at any point today because we have homework.
I'm sorry.
Are you?
Asking you to join us.
Oh, I got around the
I'm not paying attention.
I don't think she was.
You said homework.
Yeah, but I'll still in this. I know. Oh, I've got the mug.
Alright. Hey, let's go through my new example here. So we're going to do one example of like, this is really close to what your first couple problems will look like. They're going to give you a triangle. And they'll have it labeled with a couple things like, they'll say this is letter A, this is B, this is C for the vertices and the corners. And then they'll have a couple numbers in there. So maybe they'll have a 5 and a 13, let's say. And so this is basically, they give you bare minimum. That's the picture they give you. But then they ask you a series of questions about this picture in particular. So like, for instance, the questions they could ask, so these are the examples like what the book would ask for. There'll be 3 or 4 questions right after it. And it could be something like, okay, the first example might say, find angle B. Okay, so that's, maybe find the measure of that angle B. The second question, maybe it says, find BC, the length of that wall. The third question, maybe find angle A, the measure of it. Okay, so this could be an exact idea of like what the first couple problems are. So they don't explain anything. They just say they expect you to be able to find the missing part by using the trig functions or Pythagorean theorem. Okay, so you can kind of mix them together. It doesn't matter. I don't really have a preference on which one you pick, as long as that the trig function or formula that you're using actually does find what they're asking for. I think that's the hardest part about this homework is like, it's so open-ended because you can pick a lot of different ways to approach the same problem. That could be confusing for some people because somebody in the back room could approach this problem completely different than somebody in the front of the room. But I think the easiest way to do this problem is just to go one at a time and go in order. Don't try to bounce around a lot. Just go in order because once I have these, I will label the picture with the numbers we get, and then we can eventually this will mold and we can find all the rest of the parts really easily. Okay, so we're going to find angle B first. That is this angle up here. So when I first started, and this is what I would do in my homework, I would draw this picture in my homework, and then I would label the walls that they provided me. Like, for instance, what is this wall called?
Opposite.
Opposite. Now, how we know that? It's the opposite side of the picture from your angle. So if your angle's over here, that's the opposite wall. This is the opposite wall from angle. Now that I have that, now I can label the 13. That's the hypotenuse. Okay? So you need to be able to label those. The hypotenuse you should not get wrong. Like, the hypotenuse doesn't move. It's the biggest wall. The opposite could change depending where the angle sits. Now that I have that labeled, now it's kind of obvious how to find B, because which formula up here uses opposite and hypotenuse?
So,
Yeah, so sine, the first one, right? So this is going to be the formula we're going to use. We're going to use the so part of that formula because it's the only one that uses O and H, opposite and hypotenuse. That's why I gave you the little acronym, so you kind of know which one you need to pick. So sine of my angle B, is equal to, because I don't know what angle B, that's the whole goal, is to find that angle, is opposite over hypotenuse. So that's O and H. So opposite is the 5, hypotenuse is the 13. Okay, so that's the setup. So you're going to have to do that in your homework. So maybe you need to draw the picture, label it. Now I set up my formula. Now we need to solve for the actual variable that they want. So what was the rule for how do I get rid of the sign here?
You erase it.
Yeah, you have to erase it. But on the other side, you have to do the inverse button, right? You have to do the sine -1. Now remember, those inverse functions, right? Inverse sine function or inverse cosine or inverse tangent. You only use this type of function where they have a little -1 on it if you're finding the angle. You don't use it in any other case, but when you're finding the angle, like angle B in this case, it's whatever trig function you're dealing with, you take it to the other side and that's the function you're going to do. So we're going to do the inverse sine of 5 divided by 13. Now if you have a calculator like mine, you can type it in exactly how you see that. So you hit the little second key, you hit the sine, you type in 5 divided by 13, close the parenthesis, hit enter, and it should tell you the angle. Let's say it's
22.6.
22.619. Larry?
How do you know?
0.9.
Guess what the other
Crazy.
ones are?
Oh,
This is it. Wait, no, no, no.
65.
Guess what comes
That's
after
what
zero?
I said.
3.
Oh,
0.
no.
9. I don't know.
8, 6, 5,
No problem.
4.
So, alright, now hey, when we do these, try to go at least 3 or 4 decimal places. The reason being,
22.619.
yeah, so the reason being, 3 or 4 decimal places. The more accurate, the better your answers will be in the very end, the more clean they'll be. They won't have so many decimal places, especially for walls and the other angles. It just makes it a little bit easier to look at. You'll understand that why in the next part. So the next question, for the same picture, so we found this angle up here in the top. We figured out it was the 22.619 degrees. All right, now the next question is we need to find BC, this wall. So we're going to continue. So we could either do it by Pythagorean theorem, because I have my A and B and C, so I have one of the numbers is missing, so I could do the Pythagorean theorem, A squared plus B squared equals C squared, or I could just do a trig function. In fact, I'm going to do a trig function. I'm going to do tangent. Now, the reason why I'm going to pick tangent, it doesn't really matter, because I can pick really any of the two up there, because when I label the picture, this is the adjacent wall. So I know that if I'm going to pick a trig function to find BC, the wall here, I have to pick one that uses the adjacent. So I can't use sine, so I'm going to have to use cosine or tangent, because these are the only ones that have A's in them. And I can use one of those trig functions to solve it. Now, if you do Pythagorean theorem, you wouldn't have to do this. You can just solve it, it'll be a nice number. If you do a trig function, just pick one. I'm going to pick tangent, because that was the new one we learned yesterday, so I'm going to practice that one more time. So tangent of this angle. So we're using TOA, right? So tangent of the 22.619 degrees is equal to opposite wall over the adjacent wall, and the adjacent wall is the wall I'm trying to find. I'm trying to find the BC wall. That's the question I'm on. And again, it didn't matter if you picked cosine or tangent. Cosine's formula would have been cosine of this is the adjacent over the 13, so you could solve it that way. But what was the rule for how we solve for when the x is on the bottom?
Oh, yeah, just put it over yonder.
You switch these two. That was a little trick. It didn't matter if it was tangent, cosine, or sine. Is if the x is on the bottom, you just do a quick switch. Where we change the denominator and this side. So the tangent 22 will go on the bottom over here. Okay, and if we do that correctly, it'll be like 12.0000. Okay, makes sense. And again, that's why I went about 3 decimal places, because if I didn't go 3 decimal places, that number wouldn't have been as clean as it is. Especially when you do Pythagorean theorem, the answer is 12, in fact. It's perfect 12. So the more accurate your decimal is here, that actually made that one easier to work with. Now, again, did I have to use tangent? No. I could have done cosine here. cosine would have found the x as well. Just to kind of fill you in, cosine is the 22.619. Cosine, according to this formula, is the adjacent over hypotenuse, adjacent over hypotenuse. And I could have multiplied the 13 across. It would have still told me 12. 13 times the cosine of 22.6. It works. So that's I think that's the part that really gets people, is that these questions are very open-ended. If you can do them different ways, still get the same results as the person next to you, even though you used a different formula, as long as you have an understanding on like the labels and knowing which one to pick that would make sense. Because again, I'm just taking different approaches for solving these. All right, then the last one, angle A. I'm not going to do anything fancy for angle A. I think we're just going to do the common sense thing here is the angles of a triangle should add up to be 180. So this, I'm finding the last one, measure of angle A. This angle down here is the one I need to find. It's related to this one up here. They're not the same angle, but this number down here in the corner can be found because these two have to add up to be 90. So I know that. 90 plus 90 makes 180. So if I take 90 and I subtract that, I get something like, what do you get, 67 point something?
67.318. 381, my bad.
381.
Come on, Brian.
I'm sorry.
381 degrees. All right. And that, like, if I was doing something like that, I wouldn't do any complicated formula. I wouldn't do a trig function. Just common sense, you know, the leftover angle. Maybe you're that person that likes the Pythagorean theorem. You could have found that that answer was 12 right here. So that was another way you could have done that problem. Because x squared plus 5 squared equals 13 squared, you could have solved it. Okay, is there any questions with like kind of what you're going to be expected to be able to do? Okay, now I can't prepare you for every problem, but you get the idea of what you're doing, right? Sines, cosines, tangents. You got to have a scientific calculator in your hand, otherwise you won't be able to figure it out. Every answer, 3 or 4 decimal places, unless it's like it works out to be a perfect number, then you just get the whole number. So don't round anything crazy. So just 3 or 4 decimal places. Trust it. Okay. Any questions at all about what we did? What do you got?
Can you go through the Pythagorean theorem? one more
So
time?
we'll do the Pythagorean theorem to prove the 12th. No, that's fine. So the Pythagorean theorem on this particular problem, if you want to like solve it, right? X squared plus, so this is A, right? This is B, this is C for the walls, because the two legs are the smallest, they touch 90. So x squared plus the 5 squared equals the 13 squared. So let's say we're doing it that method to solve for x instead of doing the trig functions. So yeah, this would be x squared plus 25 equals 169. I would subtract the 25 across, get 144,
Okay,
and
that's...
then pick the square root, which works out to be 12. Like, it was like a perfect 12. So, and that's what our numbers kind of justify. So, question?
Someone's calling me, can I just like end it?
Yes. All right. Any other questions on what we did today? I'm going to give you some time to work today. Now, the first thing you want to do when we get started here, double check your grade online, see if you're missing anything. This is the time to work on it, get it turned in. It's the last day of the quarter. So get something turned in if you're missing it. I'll just say the names of people who are missing something. Even if you're missing one, I'll just say your name out loud. You can go online, you can check what it is. I need it today if you're going to turn it in. Okay? Because it's the end of the quarter. I'm not going to go past that. So, but here's your homework. I'm going to put it on the board here. You can move around once you get the homework. You can sit wherever you like, borrow a calculator if you need to. Okay, now I'll put it here and I'm going to put it over there so you can see it. It is page 573, 1 through 6, 8 through 10, 12 through 14, 28 through 33, and 36 through 38. I kind of jumped around. I just picked problems that has very nice looking triangles, nothing like crazy difficult. Where all they're asking you to do is find like one part, like one piece. And so like this problem I have here represents like a couple different problems. So, but there you go. Here's your homework. It's due next Wednesday. And that'll be the second assignment on this next quarter.
So much.
So, yeah, we'll kind of work it all. Okay. All right. But I'm gonna put it over here, and you guys have the rest of the time so you can move around if you need to.
Where'd your wiener inauguration go?
What?
Where'd your wiener inauguration go?
I think I put it in my my desk. That was a gift. I hope I didn't lose it.
Ethan.
I just had a lot of people in other classes.
Where can I go right now? Look.
You were one too. I don't know if you're.
How do you, this thing?
Soccer. You ever tried to do one? I got it.
Let me just go to home soccer. There we go. Great, guys. Have you run out of it? I have 2 days. I didn't take it. Okay.
Is this your last day?
We never had,
I didn't even take it.
Wanna practice your show up? Stretch a little bit. After I'm done stretching, corner kick stuff. Well, I went in the past couple minutes to figure out what I was supposed to do.